Hi, everyone. Welcome to the U.S. Research Software Engineering Education and Training Working Group Seminar Series. Today, we are very happy to have Andres Rios Tascon representing continuous integration and continuous delivery with GitHub Actions as a tutorial. First, I'd like to remind everyone that we do have a code of conduct that we ask everyone to follow, which you can reference in the link that I'll place into the chat. And if you're not yet a member of USRSC and you would like to become one, you can join the USRSC webpage, and a link will also be placed to that in the chat. This is a hands-on following along tutorial. We have a few volunteer TAs who can answer questions in the chat in case you get stuck. But since we have a lot of people here, we're offering this help on a best effort basis. So we won't be able to spend a lot of time with a single person or stop the tutorial. But this tutorial is being recorded and you can follow along at your own pace once it is released. We will also have a channel in the USRSC Slack where you can ask questions and continue the discussion after the tutorial completes. Now it is my pleasure to introduce our speaker. Andres is a research software engineer at Princeton University, working with the Institute for Research and Innovation in Software for High Energy Physics. He focuses on developing tools needed to tackle the challenges posed by the high volume and complexity of the data that will be collected at the High Luminosity Large Hadron Collider at CERN and other future HEP experiments. He obtained his PhD in physics from Cornell University, where he developed software to study the intricate geometric spaces used in the study of string theory. With that, Andres, you could get started. Thanks for being here.
Okay, thanks so much for the introduction. Let me share my screen. Let's Okay, can you see me? My screen.
Yes.
Okay, hold on. Let's go. Okay, so I'm gonna try out this thing where you can see me, just so it feels, I guess, a bit more, or a bit less like impersonal. Um, and I guess I also get to pretend that I'm a Twitch streamer or something. So yeah, so for today, we'll be talking about GitHub Actions or continuous integration and continuous delivery with GitHub workflows. So first, just wanted to do a quick self-introduction. I guess Helena already mentioned this, but so I'm currently an RSE at Princeton University. I've been here for about 2.5 years. I did my PhD in physics, specifically in string theory, and it's kind of a very different world over there in theoretical physics. RSEs are not really a thing yet, but nowadays I've been working on high energy experimental physics, where RSEs have been a thing for a while. Currently, I'm working on a couple of different projects. There's line segment tracking, which is an algorithm to reconstruct particle tracks on GPUs. And then I'm also involved on scikit-hep, which is an ecosystem of Python packages to analyze data from collider experiments. And specifically, I'm working on Uproot, which is a Python IO library for root files, which is what they use to store this data in. And I've been either developing or maintaining the CI/CD workflows for these projects, and I've been enjoying them and learning a lot about those there. So that's why today I'm sharing this with you. So first of all, let's start just from the definitions. Since you joined this session, I guess you have at least a rough idea of what CI/CD is, but let's start from the very beginning. So CI stands for continuous integration, and what that means, it's just simply the frequent merging of changes into the main branch of your project with some automated quality checks. So, like, no matter how small the changes, you're just constantly merging into your main branch. And this is as opposed to like how development was done before, where like you would assign a team to like work on some feature, then some other team to some other feature. They'll just go separate ways, and then after a while, kind of like reconvene and like try to like fit everything together. This approach, you're just constantly building on top of the main branch. And this way, you constantly are checking that everything is working well together. Then CD can stand actually for two different things, which can be a little confusing. It can be either continuous delivery or continuous deployment. They're both pretty similar, but continuous delivery just means that your code base is always in a releasable state, and you just basically need to push a button to make a release and just deploy it. This is like pretty common when you see, for example, like some repository with some Python package, like the code is always like basically ready to be deployed. You just need like some admin to go into like the release button and then push like make a new release. And then continuous deployment is where the process is just fully automated, and then every change that get merged into your main branch automatically gets deployed. This would be something for when you have, for example, some website set up in GitHub pages, so that every time you push a new change to your repo, it automatically builds the website and deploys it just fully automatically without any manual intervention. Then we just refer to CI/CDs as sort of like this whole process of automating all these things of like checking and uh, deploying and like all these workflows as a whole. So then you might ask, what can we use CI and CD for? So we'll just go through a few of the most common cases. So you can use this to run tests. They can be either dynamic or static. This way, when you're making some changes, like, or you open some PR, you can make sure that uh, all the new features or the changes that you implemented are not going to break anything that was done before, any existing functionality, or is not going to like conflict with some other changes that other people are doing. Uh, and in this way, you can also, for example, run, well, you can also make sure that the code follows formatting guidelines or some sort of like linter checks, and make sure that your code stays nice and tidy, nice and tidy, which is which is especially important nowadays that LLMs are really taking off, and you want to make sure that the code really stays high quality, that it's not going to break something, and that it's actually high quality code that gets integrated into your project. So this is actually pretty important. You can use CI/CD, for example, to build documentation. So you can have some workflow that runs Doxygen or Sphinx or whatever system you have set up to generate documentation, let's say in PDFs or HTML form, and to deploy this documentation, let's say to read the docs or to a GitHub pages or whichever way you prefer. You can, for example, also use CI/CD to check the examples that you have it in your documentation. Uh, it's pretty common to run into some documentation where you are just like going through the getting started section, and you like copy paste things into your terminal, and it just doesn't work. It just doesn't work just because the authors haven't kept up with updating the documentation. But you can actually make sure that the documentation stays up to date by actually testing the code in your documentation, and this way we'll have a much better user experience for your users. Uh, as I mentioned, yeah, you can also build static websites. This is actually pretty easy to do with GitHub pages. You can also use read the docs or whichever other things you might want to do. Uh, this way, you can, for example, set up a personal website. And in fact, you can set up some CI/CD workflow, for example, so that, let's say, weekly, it checks for a list of your publications, and then it updates the publications on your website, things like that. You can set up workflows to generate pull requests automatically for updating or doing some of maintenance of your package. So for example, you can check if there's updates for the dependencies, or you can check, for example, for typos or coding style or whichever way you might want, whichever thing you might want to check. So in summary, this is really flexible. It's a way of like automatizing things and sort of like making sure that your code stays high quality and yeah, that your project just stays in good shape. So what are the benefits of using one of these CI/CD pipelines instead of like, let's say, like running your checks locally or having some other approach? Well, there's a bunch of different benefits. I'm just gonna go through a few of them. Uh, so first of all, uh, one nice thing is that the tests or like these workflows run in a consistent and controlled environment. So like if you have some user that is reporting some issue, uh, you and they like submit it and you can't reproduce it, this can be pretty tricky sometimes. Whereas if you have like some consistent environment, you can set up some tests that reproduce known issues, and uh, you're always gonna know that these tests are gonna be run in consistent environments, and everything's gonna be reproducible. Uh, you can choose it to run in whichever way makes sense. So often it makes sense to run like all these tests and everything for like PRs or comments. Uh, you can set up things so that, for example, when you create a new tag, it makes a new deployment or things like that. It is so basically it's very flexible to choose when things run. Another benefit is that it can't be skipped or forgotten by accident. Like it is pretty common to like sometimes you're working on some project and you make some little tweak and you're like this is such a simple thing that I'm not gonna break anything. I'm just gonna push and just be done with it. Uh, if you have some CI/CD workflow set up, it's gonna run and it's gonna let you know if you actually broke something. So this way you can be a lot more confident that the changes you're making are gonna actually be fine and are not gonna break anything. And then on the other side of this is that there is no contributor setup. You're not gonna be forcing your potential new contributors to run a bunch of tests or like run a bunch of linters and stuff on their system. Instead, they just submit the fix to or feature that they want to contribute. Then everything runs on your CI/CD setup. Everything is checked and everything is it makes sure that the contribution is actually good. Another benefit is that it can run on a lot of different OSs or Python versions or setups, like compilers and so on. Whereas this would be pretty tedious to try to do manually, uh, especially across different operating systems and compilers and so on. You'll see later how we can very easily test our code on a bunch of different operating systems, Python versions, and all this. And this way you can make sure that pretty much everywhere that your code is going to be deployed is going to work, and you'll have more confidence in uh, yeah, that is just going to work for users. Okay. Then as for what your options, I guess I'm covering much. Okay. So what kind of options do you have if you want to use some of these services? So probably one of the most like early ones that are, like became really big was Travis CI. It was really popular, you would see it in a bunch of different places, but then it kind of like disappeared over time. I think people were like abusing it, like mining crypto and stuff. It kind of just like disappeared. There is Jenkins, which is still popular. This one is actually self-hosted, and it's also fully open source, which is nice. Uh, and this is actually useful if you have if you for some reason need like specialized hardware or uh, let's say you're running some code on like FPGAs or GPUs. It might be just cheaper to use your own hardware and use this. There is Circle CI, which was kind of like one of the first like more modern ones that like was very modular and nice. There's GitLab CI, which yeah, still one of the best and it's still very good. There's Azure Pipelines, which again, it's pretty good. But the one we're going to be talking about today is GitHub Actions. It is extremely simple to use. It is very popular. It is really nice because it is like very modular and you can create actions that you can share and use like from other people. Uh, and it is also free. It is fully free for open source projects. You can use like however much you want for open source. And then if you have uh, some like private repository, they still give you a pretty generous allotment of time. So it is pretty nice. Okay. Any questions about any of this so far? Let me see the chat. Okay, there's nothing in the chat. Okay. All right, yeah. And by the way, at any point, just feel free to interrupt. I guess if it's something quick, just let me know and I can address it. So I wanted to show you a couple of examples of CI/CD setups. So these first two are ones where I've worked on. So this first one is for this uh, GPU algorithm that I talked about at the beginning. And this one is kind of an interesting one because it's the tests are something that are pretty long, so you wouldn't want to run like on every commit. So the solution I came up with this is that instead of triggering every time you update your PR, you actually leave a comment with instructions for the CI specifying what tests you want to run and like specific modifiers or anything you would want. And then the bot will just thumbs up the comment to like, let you know that it understood it. It's gonna start running, and then after a while, it's gonna leave a comment with plots, so you can compare visually how the results look. It can also give you some timing comparison. You can see here some more plots. You can specify like more things in the comment. So that's one example. There's another example here. This one is, I guess, a bit more standard. It just runs every time you make up you update your PR. So it's checking, for example, that for the code coverage of your patch. So this one is letting you know that 100% of the new lines or changed lines are being covered, which is good. For example, here there's a setup where it's generating a preview of the documentation. So you can preview it before merging the PR and seeing how the documentation will look. And then it's running the tests on a bunch of different systems and Python versions. You can see that there's some GPU stuff, some Windows, different Python versions, NumPy 1, uh, Pyodide, a bunch of different things. And then lastly, just want to show sort of like a well-known repository. So this is NumPy, and just to show you that similar things are done. Like it's just running a bunch of different tests on a bunch of different systems. Like it's running some emulation stuff for different architectures. In fact, you can actually see that apart from GitHub Actions, they're using Circle CI, which today we won't talk about, but it's you can see that it's still there. And yeah, it's running a bunch of different things. So
We
we'll
have
see.
a question. Parikshit raised his hand.
So looking at these NumPy tests, I kind of wonder how much of these are like whether all of these need GitHub infrastructure, because I think a lot of projects tend to favor GitLab actually, because you can have your own CI runners and you can install them on your own machines, and GitLab, will call those, right? And so typically, like a lot of people are limited to, I think, 2,000 hours a month. And I think that's across for some organizations. If you're part of a lab, you're all fighting for those hours. So I was kind of curious if, what your GitHub sort of awareness is of what must run locally on their hardware versus elsewhere.
Yeah, so what's actually nice is that those 2,000 hours are actually just for private repositories. For anything that's public, you can use unlimited time
Oh,
because
okay.
and with GitHub Actions, you also can use self-hosted runners. Uh, Although lately they actually introduced some kind of controversial change where if your repository is private, they're still gonna charge a very small amount, even if you use a self-hosted runner, which is a bit weird, but you still have the option.
Okay,
But
thank you.
yeah, in this case, most of these things I think they're actually running on GitHub infrastructure. You can see the workflow file here, and yeah, I mean you will understand what this means later, but they're actually running on GitHub. Okay, any other questions so far? Okay, let's proceed. So the plan for today is that we'll go through a little bit of background. I'll try to be brief on this. Most of the time we'll be spending on a hands-on demo, and then we'll be doing a couple of exercises just to test what you've learned. And by the end of the session, you'll actually have written pretty realistic workflows. One, to test a Python package, and two, to deploy a static website. So let's get started with this. So first we'll do a crash course on YAML and exit codes. I assume that most of you at least are familiar with this, but just to cover all of our bases, let's start with YAML. So YAML, which stands for YAML Ain't Markup Language, it's a human readable serialization language. It is pretty easy to read and use, and it is very commonly used to configure CI/CD workflows. So you'll see this in GitHub Actions, in Circle CI, I think. Pretty sure also in GitLab. All extensions are .yml or .yaml. And this is how you define things. If you're just defining a scalar value, all you need to do is you write your variable name, and then a colon, then a space, and then whatever value you want. And this space is actually important. You need the space, otherwise it's not parsed correctly. So you can have some numerical value, let's say 42. You can have a Boolean value, like true. It can also be on or yes. This is how you do comments, just like in Python. For a string, you can use quotes, either single or double. But you can also leave the quotes out. This also works. If you're defining a list, you have two different options. One way you can do just the colon, and then in new lines, you separate the items with like starting with a dash for each item, like this. Or you can use sort of like a more compact style by using square brackets like this. And then lastly, for dictionaries, the way you define them is by sort of like grouping more values within some indentation block here. And then this is kind of like the standard thing here is to use two spaces for indentation, but that's not necessary. You can use like four if you prefer. And then there's also this other like equivalent way of defining dictionaries, which you might recognize from JSON. And this is because YAML is actually a superset of JSON. So you have that option. And then another couple of things, if you want to have multiple lines of strings, there's a couple of options you can have then. If you use this greater than sign, what it will do is that it will take all of your lines and then it will just put them together with a space in between. So this is equivalent to this text over here. And then the other option, if you want to keep all the new lines as separate new lines, you can use this vertical line like this. And then all of this text and end up being equivalent like this with new line characters in between. And this will come in handy, you'll see later on once we write some scripts that have like where we want to run multiple commands. Okay, that was it for YAML. Any questions on YAML? Should be all you need for YAML right now.
There's one question in the chat.
Oh yeah, there are a few different versions of the standard. Yeah, I think there's some different versions, but for today you like they don't really matter. Like we're just using the very basic syntax, which is the same in all versions. Okay, and now let's move on to exit codes. So this is something I need to keep in mind because the way CI/CD pipelines work is that they will run a bunch of commands and they will be checking for the exit codes of each of these commands, because if it detects that some command didn't run successfully, it will just stop and give you some error. So you might be familiar with this, but every time you run a command in a shell, there is an exit code indicating if the command ran successfully or not. An exit code of 0 indicates that it was successful. And other commands or other exit codes usually mean that there was some error. And sometimes, although not always, different numbers correspond to different errors. So here's a very simple example. If if you just like echo hello world and then you pipe it into grep, and in this grep you're searching for the string hello, it will actually find a match, hello world. And if you echo, then this is a special syntax for bash. So in bash, the question mark variable is the exit code of the previous command, which in this case is this whole thing. So if you run this and then you echo this exit code, you'll see that it's 0. But then if we do the same, we just echo hello world, but then we grep for Python, it won't have any match. So then if we print the exit code, you'll see that it's 1 because there was no match. And if instead we grep for some pattern in some non-existent file, it will give us some error saying that the file doesn't exist. And if we see the exit code, you'll see that it's 2. It was a different thing than before. So that's how it works. So if we run this on a CI, this command would be successful. And then this one, since the exit code is non-zero, it would think that there was some error and the CI would just stop there. Yes, as I mentioned, CIs typically stop once they encounter a non-zero exit code, but sometimes you may need to run a command that might fail, but you still want the workflow to proceed. Or sometimes you might find some script in the wild that don't respect this standard and they just decide to return a non-zero exit code even when they work successfully. So in these cases, it's convenient to know this trick. What you can do is kind of like abuse a little bit the logical OR operator, because the logical OR, the way it does is that it runs the first command, and if that one succeeds, then it just completely ignores the rest. But if this command fails, it will move on to the other side of the OR and run this command. So what you can do is just write something on this side that you know that is gonna work, like just echo, ignore, or something like that. And what it will do is that once this fails, it will just echo ignore. It will just print ignore, and then the CI will just continue without any issues. And then just for completeness, you can also you can also conditionally run commands only if a previous command works with the logical AND operator like this. So in this case, this command will run. If it fails, then the whole thing will just fail. But if it runs, then it moves on to running this other command. And then it will just continue as usual. Okay, and that's it for exit codes. Any questions on exit codes? Okay. Let's move on. So now we're actually going to start looking into how we can set up a GitHub workflow. So GitHub workflows are configured by placing a YAML file into this directory .github/workflows. They can be set to trigger by a wide variety of events. We're just going to cover like the main, the most used ones. And they can run your own commands, or you can use actions that are written by someone else. And we'll see both of these cases, how to do them. Just so you have some basic idea of how things are going to look. This is the rough structure of how it looks. So with the on keyword, we specify when the workflow is going to run. And then we have jobs, which is a dictionary of all the different jobs that we run in our workflow, each of which we specify where the job will run, as well as the steps that the job will take. And each of the steps can either run some command or they can use some third-party action. So, okay, so this is just so you have a rough idea of how it looks before we begin, but I think we're ready to begin. So any questions before we begin? Okay.
So is the run a shell action when you put command or?
Yes. Yeah.
Okay.
So run would just be some like shell command, and we'll see this in a second.
And you can use pipes in there?
Yes. You can use anything you would use in a normal shell. What's the folder structure here?
Yeah, sorry, it's nested in a .actions directory, you said? Like before, I'm just trying to mirror this.
Oh, in this one, the .github/workflows, or what do you mean?
Yeah, that's it. Perfect. Thank you.
Okay. Yeah. So yeah, we'll set up all this structure in a sec. So yeah, so let's start with the hands-on part. So what I want you to do is go to this link over here. Let me copy and paste it in the chat, although it should already be in the chat, but let me just post it again. I'll give you a second. So you end up in this GitHub repository. And what we will do is that we will go here to fork. I wonder what happened with my screen. Okay, so we will go over here to fork. And then by default, they should choose your username here as the owner. You can just leave the repository name the same. And then you can just hit create fork. And then in a couple of seconds, you end up in something like this. But now it should be under your username over here. Okay. Hopefully everyone is with me. Okay, so now here's a trick that you might not know, but it's actually pretty useful. If you're here at a GitHub repository and you press the period key on your keyboard, this is what happens. It opens VS Code on your browser. And this actually VS Code, like actual VS Code, is which is really convenient. You can this way, like if you're just like borrowing a computer, like on the library or something, you could work on some GitHub project here, and it will work well. You can even install like extensions and stuff. The one thing you don't have access to is a terminal. But if you do need to run something in the terminal, you could use GitHub code spaces instead. But for today, this will be enough for us. Okay. So hopefully everyone is here. Okay. And one thing I did forget to do earlier is to just delete this directory over here. Let me just fully delete that GitHub. So we can start from the beginning. Okay. Is everyone with me?
So just to reiterate, you just deleted your .github directory, right?
Yeah, let's fully delete it. Sorry, I should have done
Okay.
it before. I forgot.
It's fine.
Okay. So now we're starting from scratch, as if this was a new project and we're just starting. In fact, let's just go over here and commit, just say something like deleted workflows. And so we start from scratch. Okay. So the very first thing we'll do is we're gonna create the directory structure that we need. So we can right click and we can go to new folder, or you can also use this button over here, new folder. And then over here we'll do that GitHub/workflows. Then you can press enter. See, are there any questions? Oh, yeah. So this VS Code in this way doesn't actually eat anything. This is completely free. The one that does eat into your usage is code spaces. This one is unlimited usage and that doesn't, yeah, you don't need to worry about anything. Okay, so now we have this directory over here. And then within here, let's right click and let's go to create new file. And let's call this file, let's just call it ci.yml. Okay. So here we just need to specify two things. One, we need to specify when the workflow will run. And then we also need to specify the jobs that will run. So first, start with on. Okay, so we need to specify on, and then we need to specify the jobs. So for on, let's keep it simple for now. Okay, let me change this indentation to 2 because I like it better. So we'll say that it will run on pushes for now, and that's it. And then for jobs, let's only create one job for now. Let's call it hello. For jobs, we need to specify two things. One, we'll need to tell it which system or like which platform it will run on. This is with the runs on value. For now, let's do Ubuntu latest. For here, there's a few options. So there is Ubuntu latest, Windows latest, macOS latest. And then there's a few versions of each of these. So like for Ubuntu, there's 24.04, 22.04. I don't remember if there's other options. Actually, for Ubuntu, there's also 24.04-ARM, which runs on ARM, as the name suggests. And for macOS, there's 14 and 15, I think. Okay, so that tells it what kind of platform it will run on, and then we need to specify the steps that it will take. So this will be a list of steps. And I will just keep it to one step. And what we'll do is that we'll tell it to run some particular command. Actually, it's run, not runs. And for now, let's keep it simple and let's just say echo hello world. Okay. So that should be it. That's basically as simple as you can get. So we'll go over here to this button. We will write some commit message and say added CI. Like this. Then we can commit and push. Okay. Then what we can do is actually, well, what you can do is you can duplicate this tab. And then to go back to the repository, what you can do is instead of github.dev, you can go back to github.com. That will take you back to the repository that you just created. So can you privately host GitHub Actions? Yes, you can have a self-hosted runner. I mean, we won't be covering that today, but yeah, you can do that. Although if it is a private repository, it will consume a little bit of your allotment, but that's not too big of a deal. Okay, so now you'll see that we have this commit that we just made, and you'll see that now there's a check mark over here. This is actually the job that we just created, the workflow that we just created. If you click over here on details, you can see more details. Or you instead, what you can do is you can go over here to the Actions tab, and you'll see over here that there's this workflow run. And in here, you'll see that, well, it's for the CI.YAML workflow that we made. And you'll see over here that we have this echo hello world step that is printed hello world. Okay, so that's the most basic thing we can do. Any questions so far? Okay, so let's go back over here. By the way, can you read this well? It should be clear, yeah. Okay.
Yeah, it's the perfect size for me.
I have
Yeah,
a-
if anybody, oh, sorry, go ahead.
so how do you know that the CI ran? Usually there's like a check mark, but I don't see it.
Oh, so yeah, there should be a check mark right here next to your commit message. Or if you go to the
Oh,
Actions tab, there should be a workflow run there. It could be
oh,
that,
okay, it failed. That's why.
oh, okay. Yeah, sometimes it's easy to make some typo, like if you leave off some space or something, you can have some issues. What is nice about this VS Code thing is that if you make some mistake, like let's say we didn't put that space there, there should be something highlighting that there's a mistake.
Yeah, I typed runs instead of run. So and it
Oh,
actually does tell me, which is I don't know, my experience with CI tools is like it usually doesn't tell you what the problem is. I'm pleasantly surprised. Like it is
yeah,
actually giving me something helpful.
yeah. I think they've done a good job with this. And yeah, sorry, I think that was my mistake because I wrote runs first. Sorry about that. Okay, so this is as bare bones as we can make it, but we'll improve it a little bit just to make it a bit nicer. So you'll see here that we have this ugly name over here, and that over here we just have things that are not very descriptive. So what we can do to make things a bit nicer is that we can use the name keyword in various places. If we use it out here, what we'll be doing is giving a name to the entire workflow. For example, we can call it my CI workflow or something. And then here in job, by default, it just picks up whatever this identifier is. And we can give it a nicer name. Let's call it, I don't know, my CI job. Let's call it my hello job. And then even within the steps, we can give each of the steps a nicer name. Uh, just so like if we have like some really long, ugly command, we can identify it more easily. We can call this one like print hello world or something. And then you can see that, let's comment this again. Just call it like added names. And commit and push. Then let's go back here. Let's go to the Actions tab. You'll see that there's this yellow dot, meaning that it's running. Okay, that ran pretty quickly. It didn't give us time to see. But now you'll see that here. Okay, let's actually go back to the Actions tab. You'll see here that now instead of like some path name for the file over here, now we have a nice name over here. And if we go into that workflow, you'll see that now this job has a nice name. And then within the job, you'll see that this step has a nice name. So this way you can have things be a bit more legible and more easily identifiable. Okay. Any questions so far? Okay, if not, let's go back here. And let's try just making a bit more complex. So instead of having a single step, how about we add another step? Let's call it, I don't know, second step. And let's make it run. Let's see what's something good to run. I don't know. Not very creative, but okay. Let's just make it print second. And let's also just have a second job, just so you can see what it would look like. Let's call it goodbye. So again, we can give it a name. Let's call my goodbye job. We again need to specify which platform it needs to run on. For this one, let's try out Windows, let's say. And again, let's use the latest version. And then for steps, I'll just make it simply print goodbye. And then just to make it a bit more interesting, what we will do is that we'll make this goodbye job run after this hello job. The way we do this is with the needs keyword. So needs takes either a list or the name of another job. So in this case, since we want this job to run after the hello job, then we'll tell here that it needs hello. Okay. Then what we can do is here, let's create a new commit. Just say add a new job. And let's commit and push. Then let's go back over here to the Actions tab. You'll see that now there is another workflow running. And now you'll see that there's two different jobs, and you'll see that they are connected here. So what it will do is that it will first run this hello job. Then once it finishes and it's successful, it will move on to running this goodbye job. Why is it taking so long to run?
We have a few questions in the chat
Oh,
while
yeah.
you're waiting.
Oh, yeah. So by default, the jobs run in parallel. If there are no dependencies, it will just try to like start up every job it can. But if there's some sort of like, yeah, if there's some sort of dependency, either because you want to check something first or because you want some step to like, let's say like build the package and then another job to like take that build package and do something else with it, then you will use this needs keyword and then you will just run them sequentially. Oh yeah, sorry. So under this goodbye job, we added needs hello, which will tell it that this job needs this other job to first run before this job can be executed. Not sure why this is taking so long. Okay. Yeah, I have no clue. I took a minute to print a couple lines. Okay. Okay. Questions so far?
Just related to the issue we're having there with it taking a while to run, is that something you've noticed in general that sometimes it can be buggy in running through um the kind of pipeline?
Usually it's pretty good actually. In fact, it's like consistent enough that like for some of my projects I do like benchmarking tests to like compare timings between uh like the old sort of like the main branch versus the PR branch. I don't know what happened in this case, but usually it's pretty good. Sometimes they do have issues and you can track them with so there's this GitHub status. Okay, there's some issue right now, I guess. But yeah, you can see that over here, actions is fine today. I mean, yeah, it's had kind of like a rough patch, I guess, with the past 90 days, but usually it's pretty good. Okay. You have more than one needs dependency. Yes. So if you have multiple jobs that it depends on, instead of specifying just here a single one, you would put them into a list. So it would be something like this, which in this case, another job doesn't exist, but it would be like this. And then over here, if you look at this graph over here, you will see that there's like a joining over. It's a pretty good visualization, I would say. Okay. Any other questions? Okay. So now so far this was kind of like a very bare bones example that's not really doing anything interesting. So now let's actually do something that's interesting. So you'll notice that in this repository we have a bunch of files, and you'll see that they actually correspond to a Python package. You'll see that there's this pyproject.toml, and then there's this source CI/CD example. If you look into it, you'll see that it's like a very silly Python package that doesn't really do much, but it has like the whole setup of like a real Python package. Like he has some code, he has some tests over here. You can see here. And like he has the PyProject that TOML that you need for a Python project. So let's actually set up a CI workflow to test this Python project. So I guess let's leave these jobs as they are. Let's set up a test. Yep. Let's give it a nice name. Just call it test the Python package. And then for now, let's run this on Ubuntu list as usual. And then for the steps, let's see. So we would want to test the Python package. So what we want is to first install it and then run the tests. You'll see that if you look over here, the PyProject.toml, you'll see that it has these optional dependencies for PyTest. If you're not familiar with Python, don't worry too much about this. Like if you usually work with some other language, don't worry too much about the Python details. But I figured that Python is pretty common, so probably most people will be familiar with this. So let's have two steps, one that installs the Python package, and then another step that runs the tests. So for this step, let's name it install the package. And what it will do is that it will run this pip install then period, which means like the package in the current directory, and as with the optional test. Was it test or tests? It's test with the optional test dependencies, and then we'll have a separate step where we run the tests. Let's name this run the tests. And then the command that it will run will just be pytest. Let's actually make it very verbose, which usually for CIs is a good thing, so that you can go back to the logs and figure out what happened and what the issue was. Okay. So in summary, we have a new test job that has two steps, one that installs the package and one that runs the tests. Okay, so let's commit this and see what happens. Let's say added test job. Okay, and then let's go back here. Go to the Actions tab. Again, there's something running, so let's give it a second. And yeah, so you'll see here that now these two are actually running in parallel, but then this other one was waiting for this my hello job to complete. Okay, but you see that something happened. There was some error in this test Python package. Let's see what's happening there. Okay, so it says that neither a setup.py nor a PyProject.toml was found. What is happening here? We clearly have a PyProject.toml here. So why do we get some error? Well, the answer to this is that for CI jobs, this sort of like virtual machine that is running this job is it's like a complete clean slate at the beginning, and you need to like basically set up everything that you want to use in it. So it comes pre-packaged with a bunch of software that is common to use. So that's why pip worked, but it doesn't make any assumptions of like what kind of repository you want to work with or anything. So we actually want to tell it which repository we want to check out. Okay, then how can we do this? Well, of course, we could do something like run and then git checkout some path, so like the link to our repository. But the people at GitHub figured that this was a very common task and people are going to be using it all the time. There's no directory structure at all. Yeah, so if you do ls as a very first step, you'll see that you're in a completely empty directory. And I mean that's by design. So the people at GitHub figured that this was this is a very common first step to just check out your repository. So they made an action specifically for this, and this is the first case where we'll see how to use an action or like a step that someone else wrote. So now instead of using this run keyword, what we'll do is we'll use the uses keyword. And then in uses, you'll specify the path to the action that we want to use, which in this case would be actions/checkout, which is the action that will check out the repository. Now you might be wondering, how do we know what to put in here? Well, this is actually just a standard GitHub repository. Let's copy this and let's go to github.com and then slash, and then let's paste it over here. So /actions/checkout. You'll see that this will take us to just a standard GitHub repository that contains this action. You'll have some documentation of the action. You can see like how to use it here. You can see, for example, that you can specify which repository you want to use, or some specific like reference, like commit or tag or branch. It has a bunch of different options. So you can look through those later if you want. But for today, we'll just be using it sort of like in the most basic way. And we don't need to specify any of these like extra parameters. But the thing that we do need to specify is which version of this action we want to use. And when we need to specify it using this at and then the version, which in this case, the latest version is v6, seems. Yeah. So we can do at v6. And this what goes in here can be either a tag or a branch name or a commit hash. But usually the way people set up these actions is that they have sort of like a moving tag where they update this tag every time there's a new commit within the same like major version. Okay, so we'll use this action to check out the repository, and by default, it's gonna check out the associated repository, like where this, like the associated repository from this CI/CD workflow. As before, we can still give it a nicer name. We can say like check out repo. Okay, so now we will check out the repository. And then another similar thing that we want to use is that you'll see over here that we used pip, but we have no clue of what Python version it's using. And Python is something that it's pretty common to have like different versions, and you might want to use different versions for different things. So they also have a similar action to set up some specific version of Python. And if you, one thing I forgot to mention is that this actions organization is like official, is made by GitHub, and so they put like all the like many like very common actions that you might need there. In this case, we want to use Python. So if you look at Python over here, you'll see that there's this setup Python. Again, you can look through documentation, but for right now, all we need to know is that, so, okay, so it is action, and then setup dash Python, and then add. Need to check what's the latest version. Seems like it's V6 also. So at V6. And then for Python, we can use this with keyword to specify to pass more arguments into the action. You'll see that we can specify the Python version like this. So we can do Python version, then colon, then our Python version. So what should we use here? So if you look at the pyproject.toml, you'll see that the minimum required version is 3.10. Well, let's just write 3.10 here. Okay. Now, there is a small bug here. If you are familiar with YAML, you might notice it, but let's just try to see what happens here. It's a subtle thing that it's easy to run into, and I'm specifically doing it wrong just to show you what happens. But I guess before I commit any changes about how I set this up, yes, let me also add a name here. Okay. Any questions about any of this?
Would you recommend just defaulting to the latest version of whichever action you're using?
Usually, yeah. I mean, that's usually the best thing to do. If for some reason it doesn't work, then I mean, then you can try other versions. If you are, well, there's some actions where instead of having a recommending a specific version, they just tell you to point it to like the main branch or the develop branch or something. Those can be a bit more annoying because they can break more easily. But yeah, I mean, usually just use the latest version or whichever thing they recommend in the documentation. And again, this is so actions are just standard GitHub repositories. The only thing is that they have this, where is it? This action.yaml file within that repository, which is what defines the action. So even though this action is set up officially by GitHub, you can write your own actions, and you can also use actions written by other people. We won't go into this today, but it's actually pretty easy to set up and pretty similar to how you set up this CI/CD workflows. Any other questions? Oh yeah. Yeah, thanks for that link. Yeah, so there is an actions marketplace where you can find actions more easily, which is also nice. Okay, but for right now, let's commit what we have so far and let's see what happens. Let's say, okay, so now let's go back to this actions tab. Oh yeah, that's a good point. Yeah, for actions written by other people, it's a lot safer to use commit hashes instead of tags, because if the repository gets hijacked in some way, people could just update the tag, and then whichever repository uses that action could be also compromised. Whereas if you use a specific commit hash, then that wouldn't happen. Okay, so if we go into this workflow again, we see that there's still something that went wrong. Let's click here and see what happened. Okay, so it says version 3.1 was not found for Ubuntu 24.04. So why is this trying to get version 3.1 of Python when we specified 3.10? Well, the reason is that, as I mentioned at the very beginning, well, like when we were talking about YAML, yeah, if you just give it a number, YAML will interpret that number just as a number. It doesn't know that it's a version. So numerically, 3.10, of course, is equal to 3.1. So it will just take this number as being 3.1 instead of 3.10. So what we really need to do here is put quotes like this to force YAML to interpret this as a string instead of as a number. And this is a pretty easy mistake to make. So you should always make sure to specify versions as strings specifically instead of numbers. Okay, so let's make this commit just so you can see how it works. Okay, so let's go back to the Actions tab. And there's something running here again. Let's see. Oh yeah, so now you can see that in this setup Python step, it successfully set up CPython 3.10. Then in this step, it installed the package with pip. And then in this other step, it ran the tests successfully with PyTest. Everything passed. So we just got a check mark in this job. So we have now successfully set up a CI to test our code. Yeah, so questions so far? Okay, so we're actually pretty close to having a very realistic testing setup. The last thing we'll look into is how we should set up this on these like triggers for the workflow. So right now it's just triggering every time we push, no matter which branch it is and like no matter what. And importantly, it's not specifically being triggered by pull requests. So we want to change this and set it up so that when someone opens a pull request into this repository, the tests will run and we can check if that PR is good. Okay, so
We do have one question.
tell me what to what. Oh, during the cleanup over here. Yeah, I mean there's certain actions that need some like post cleanup, but you can just ignore this. It doesn't really matter. I guess unless you're setting up a self-hosted runner, in which case you do have to worry about cleanup and it's a bit annoying to take care of. But for the most part, uh, since all of these are sort of like virtual machines that like get spun up and down, you don't really need to worry about all this cleanup. Okay. So now let's talk about these triggers. So far we've only talked about push. There is also the pull request trigger, which as the name suggests, it will trigger when opening or modifying pull requests. the thing to keep in mind is that if you have both of these, you might actually end up with repeated workflows just because it will get triggered. Like if you open a PR, it would end up being triggered both by a push and a pull request. So if you have both of this, then it's a good idea to limit the scope of when this push trigger acts. And you can do this by specifying which branches uh, it will trigger on. And for right now, let's just say that it should only run on them when we push the main branch. Or pull request, we can just leave it as is. And then one other one that I wanted to show you is this workflow dispatch, which it will allow us to run workflows manually. And optionally, you can even have inputs, which I won't cover today, but at least I wanted to show you how you can run some of these jobs manually. This is useful for, let's say you have some website and you have some workflow that checks your list of publications and updates your website to include that list. And let's say you have it set up to run every month, but you just publish something and you just wanted it to be updated right away. You can just click on this manually. So as I'll show you later to run the workflow right away instead of having to wait. Okay, so that should be it. So let's just call this data triggers. And let's commit and push. We'll go back over here to the Actions tab. We'll be running again. Oh, okay. It will be exactly the same as before. But if you go here into the Actions tab and you click on your workflow over here, so this my CI workflow, now you'll see that you have this button over here, and it will tell us that the workflow has a workflow dispatch event trigger, which is why it's letting us trigger it manually. So now if we go here, we can manually run this workflow. And you can actually set this up so that there's like inputs here. But for right now, let's just try running it manually just to see how it looks. You'll see that it just starts running the job as if it was triggered by some push or something. But yeah, it was just manual. And then since we also have a pull request trigger, what we can test it right now by trying to make some pull requests. So let's say we're working on some code, and let's say we make some modification here. We change this to a 3, and then here we're doing create a new branch and start a pull request. And then we'll just do here propose changes. And then let's hit over here and create a pull request. And just leave it like this. So now you'll see that, yeah, in a second, the workflow starts running. You'll have all the different jobs down here. And you'll see that, okay, this one was successful. Let's wait for the other ones. Oh yeah, so you'll see that this other one failed. And this is how, oh yeah, and since we run PyTest with the very verbose output, you can see exactly what happened and what went wrong. So this way is how you verify that the pull requests that someone opens for your PR actually work and are correct. So we have fully successfully set up a realistic testing CI/CD workflow. Okay. Questions about any of this?
Just one question about the Python version. It seems like it should be, um, I don't know, there should be a way to get your action to automatically recognize the Python version that you need from your pyproject.toml. Is that possible, or is it, I mean, I realize it's kind of circular, but does that make sense? Like it seems like you've hard
Uh,
coded the Python version here, and so you would have to go back and update that if for some reason you updated your pyproject.toml in the future. So do you just have to, is that just the case? That's the fact you have to remember to do that, or is there a way to get it to do that automatically?
well, you have a few different options. So the thing is that usually you wouldn't want just a single Python version. You would want to actually test on multiple Python versions that to make sure that it works.
Okay,
But
fair.
you also have the option of so instead of using this setup Python, what you can use is should be setup UV, but I don't actually know. Let me see. Oops, it shouldn't be. Mm. So if you use UV should actually be able to look at the Python version from the pyproject.toml and install that Python version. But yeah, I mean, this is I'm only showcasing sort of like the simplest approach, but there's plenty of
Sure,
other
okay.
options that
Yeah,
for you
okay.
to explore.
Thank you.
Okay. Any other questions? Oh, okay. I actually didn't realize that. So someone said in the chat that if you don't supply the Python version, he will try to resolve the Python version from that Python version file. Okay. Okay. I'm not sure if it. Well, okay. I guess that's something for you to explore later. Okay. Let's see. Any other questions? Okay. So the last thing we'll do before moving on to an exercise is so far we're doing our testing on the latest version of Ubuntu, and we're only using Python 3.10. So now the question is, what if we want to test on a bunch of different operating systems and on a bunch of different Python versions? How should we set this up? Well, I mean, the most obvious approach would be just having like a test Ubuntu or something, and then like copy paste this a bunch of times, like the different operating systems and so on. But I mean, that would be pretty horrible if you want to modify something of your workflow. That would be pretty annoying to like have to go through like all these different copies and update everything. But luckily, well, GitHub realized that this is something that's pretty common and that people will want uh, to use all the time. So what you can do instead is that you can set up what's called a matrix. And the way we do this is by uh, adding here strategy, then within here matrix. Then within this matrix, you can set up uh, sort of like lists with all the different options that you want to cover. For example, let's create some list that is Python version. And then within this, let's say that we want 3.10, and then also let's do the latest one, 3.14. This is okay. And then apart from that, so that will be for the Python version, and then for the platform, say we want to run on Ubuntu, which I guess this one doesn't really need to be with quotes. Ubuntu latest, Let's do macOS latest, and then Windows latest. So what this will do is that it will create all the different possible combinations. So it will do 3.10 with Ubuntu latest, 3.14 with Ubuntu latest, and then all different ones like this. And apart from that, you can also explicitly include or exclude options. Let's just do a quick example of the include. So apart from all these combinations, let's say that we also want to include Python version, let's say 3.13 with platform, let's say Mac OS 15. So now it will go through all these different combinations as well as this extra one that we included down here. So now what we need to do is we need to replace this hard-coded 3.10 in the Python version that we have down here into the one that is being set up from the matrix. And we do this with a special syntax that's used for GitHub variables. So it's $ and then 2 curly braces. And then in here we can do matrix, then dot, the thing where, well, the variable that we want, in this case, Python version. Then similarly here, we're gonna replace the thing that we had in runs on with $, the curly braces, and then in here, matrix dot dot. And that should be it. So let's commit this. Let's do edit matrix job. And let's commit. And so you can see how it looks. Let's go back to actions. And let's see how this looks now. So now you'll see that now, instead of having this be kind of like a single job like this, you'll see that now there's 7 things running here with all the different combinations. So you'll see that this one is 3.14 Windows latest. This one is, was it not, was the tooltip up? Okay, well, we can see them on this side. So there's 3.10 Ubuntu latest, 3.10 macOS latest, and so on. And in this case, well, we'll see that all of them passed. So this way we can very easily test across compiler versions, operating systems, Python versions, NPM versions, or whatever is relevant for your project. Yeah, so that's how you set up a matrix job. Any questions so far? Okay, so let's actually start with the first exercise. So if you go back to the slides, yeah, let me kind of scroll down. Can Is this good? If you want to, if you
Can you
want,
just go a
you
little
can.
bit lower? I can't, your face is in front of it right now.
Oh, sorry.
Uh, like just scroll a little bit farther down so I can see exactly what's within the $ brackets. But okay, Python version, matrix dot. Okay, sweet, thanks.
I forget that my face is in the way. Actually, maybe I should move myself to the other side. How do I do this? Mm, Oh yeah, okay, that's better. Less in the way now.
Is the matrix terminology arbitrary? Like just because you called it matrix, or is it like under strategy, or is that what you need to use every time?
That's what you need to use every time.
Okay,
Yeah. What's arbitrary is these values over here.
okay, thanks.
So like if yeah, let's say if you're using npm or something, well, you can just name that whatever you want. Storage for passing things. Oh yeah, so for passing things between jobs, that's actually something that we'll do later for exercise 2. Yeah, so I'll get back to that point. But for right now, let's go back to the slides. Let's do this exercise 1 first. So this first exercise well, should be relatively straightforward. So what you'll do is that before we run this test, we want to add a job that does some linting by running rough. So you can use rough either by pip installing it using pipx, if you're familiar with it, which is actually pre-installed in all these runners. Or you can use this Astral SH rough action, which again is just a repository, so you can easily find the documentation. So it should run rough check, and only if that step passes, then it will run the tests, this matrix of tests. And I'll point out that in practice, it's more common to use something like pre-commit to do this kind of linting. That's a topic for another day. So yeah, I'll give you a couple minutes. Maybe let's say like 3 or 4 minutes. In the meantime, I'm happy to answer any questions.
Yeah, just for a time check, we have about half an hour left.
Yep.
Yeah.
Okay, so how are people doing? Since you're just running the rough tool, you don't need to set up any Python or anything. And pipex is already, oh, the question is specifically for pipex. No, so pipex is already pre-installed, and it's I forget if it's Python independent, but you don't really need to worry about setting up Python for pipex. Okay, I guess in the interest of time, maybe let's see how we can do this. So if you prefer to pip install it or use pipex, that's up to you. what I'll be looking into is just using this third-party action. So again, this is just some repository. Let me paste it here. And let's see how it tells us to use this action. So it's telling us that we can simply use it just like this. So let's just copy that. And again, where it says, so, oh yeah, so by default, what it will do is that it will run check, which is exactly what we want to do. So if we go over here, what we can do is we can set up a new lint job. Let's name it run linter. Let's do runs on Ubuntu latest, and then the steps. Just need this one step. And also we need to check out the repository. Oops. And that should, oh no. And then apart from that, we also want this test job to only run if lint completes successfully. So we can also add needs and then lint here. Let's commit this and see what happens. Okay, so let's go back here to the Actions tab. We're here. So now you'll see that we have this run linter before the matrix of tests are run. And you'll see that we got some error. This is like a toy Python package, so I didn't really put any effort into linting anything. So we'll just ignore this. But yeah, this is how you would set it up. But just so we can continue, let's just ignore this. And I'm gonna just remove this lint job. Okay, so one last couple things I wanted to mention quickly. If you have something like a matrix of jobs, sometimes you want to run some steps specifically only for some cases. So for example, if we're running things on like macOS, Ubuntu, and Windows, sometimes you need like a special step for Linux or something like this. And you can do this, you can run either steps or even jobs with some condition by specifying the if condition like this. So, for example, if let's say we want to only run this step when our Python version is 3.14, we can do matrix dot Python version equals 3.14. And actually, in this case, you don't need the $sign and two curly braces. You can just leave it out. Let's just call it conditional step. And let's make it run, let's say, using Python 3.14. And then if we commit it and push, and go to the Actions tab, we will see that for something that has Python 3.10, for example. Just wait a second. Oh yeah, so you'll see over here that this step was just skipped. because Python was not 3.14. But if we go to something where Python was 3.14, then you'll see that this conditional step actually ran. So the same thing applies to something like the operating system or other things. For the operating system, it's an easy, there's some easier way than using this directly. Believe you can do something like if it's like platforms, or actually no, I think it's runner that runner.os equal to Linux. You can also do something like this. And again, it's convenient to use something like VS Code because it gives you like all the options, like what you were saying earlier, like do run that, and then we have all the different options. But yeah, so this step shows only run on Linux. Then the last thing I wanted to mention is that steps and jobs can have outputs. Let me see if I have time. Okay, I'll do it real quick because we're running short on time. You can make a specific step have an output. Well, I guess and this is also a good time to talk about this multi-line syntax that I mentioned earlier. So if we put a pipe like this vertical line here, then we can put multiple commands within this one step. So what we'll do here is that we'll echo, and then we'll give some variable name, let's say like message, then equals, then can, I don't know, write something here, my message. Then we can use this special syntax. We give this into GitHub underscore output. And then we need to give this step also an ID. Let's call it like hello step or something. And then from another step, we can, oops, we can look at that output. Again, with this special syntax. So now this would be steps dot, then the name of the step. So in this case would be hello step, and then dot outputs, then dot, and then the whatever we put here, in this case message. And this way we can pass specific strings before, between steps. I mean, usually it's not particularly useful. It is useful, it's when you're using a third-party action that produces some sort of output that is useful, or when you're passing messages between jobs, which is set up in a very similar way. But for now, let's just try to see this and see how it works. Okay, so let's go on to actions. Let's see. Okay, so in the second step, you'll see that it printed my message, which is something that was created in this hello step. And again, it was put into this GitHub output, and then from a different step, you accessed it with steps that the step ID outputs, and then the name of the variable. Okay, and there's plenty more things to learn about, but I think this is really all the basics you'll need. So what I wanted to do for the second and last exercise is that we're going to create the workflow that generated and published these slides that you're looking at to GitHub pages. And I gave you here sort of like a checklist for the things you need. So you're familiar with checkout and set up Python. I'm using this markdown slides, which is a Python package that can be installed from here. You can find the instructions there. And then here is there's a couple new actions that you'll see here. And this is where I come back to one of the questions that was asked earlier. This is how you can pass some sort of data between jobs. So so there is a upload artifact where you can upload some sort of zip file or data into sort of like a temporary container that then other jobs can download and use. This one is a special version that, apart from uploading an artifact, it sets up sort of like some config for pages. And then there's this other deploy pages action that actually deploys a GitHub pages website. And for this, you also need a bit of extra config. You need to go to your repo, go to settings, pages, source, and select GitHub Actions. Yes, I'll just give you the rest of the time to work on this. And I'll be going slowly through each of the steps and answering questions along the way. Let me check the chat to see if there's any questions. Oh yeah, so there's only one run directive per step. But if you want to run multiple commands in that step, you can do it this way by doing this vertical line so that then you can have like a multi-line script within here. Yeah, and we had the rough fails that was expected. Okay. Yeah. Oh yeah, if it is a little bit weird, if does need to be like the things here do need to be like single quotes for some reason. Not entirely sure why, but I guess that's just how they set things up. I don't know if that's an old question, but I'll show the steps again here. Okay. So I'll let you work on this, and again, I'm happy to answer any questions. The previous slide. This one. So yeah, you can see the slides yourself if that's why I'm also in the way. Oh, yeah, the link to the slides was shared a couple comments below or above. Oh yeah, so to see what the echo statements print out. So once the job completes, you probably will like hide all the output from all the steps. If there was an error, by default, it just like takes you to where the error was. But if it's if it completed successfully, it will just hide everything by default. But you can just open I show this here to like see all the logs, and this is where you'll see the output from the echo. And you can also like show exactly what the commands were. Oh yeah, that's a good question. If you have multiple GitHub workflows within the workflows folder, if you want to have some sort of cross dependencies, it gets a bit trickier. You can do that, but then you have to set up some sort of different workflow trigger. There is a workflow trigger that's called, what's it called? Something like workflow. Okay, I actually have an example of this that I worked on like a month ago, or actually no, it was probably like a few months ago. So here I have this docs preview. Oh yeah, so there is this workflow run trigger that runs when certain other workflows complete, or something happens with different other workflows. In this case, it runs when this docs workflow completes. But yeah, you can do this kind of things. It just gets a bit trickier. Let's see. Reading GitHub else only on Windows. Oh yeah. Well, that's interesting. Yeah, I guess the thing is that in Windows, by default, it uses PowerShell instead of Bash. You can tell it to use Bash, but I actually didn't know that this syntax wouldn't work for Windows. That is a bit interesting. It's weird. Yeah, I didn't know. I wonder if you so in each step you can also explicitly specify the shell. So you can do something like shell, then bash. I wonder if using specifically bash for that step, uh, if it would work for Windows like that. Not sure. Okay, let's see. Okay, so I guess we only have 6 minutes left. So I'll start going through some of the steps. So of course, the very first step will be just checking out the repo, which you've seen before, so I won't cover in any detail. And then setting up Python, again, pretty straightforward. The next thing that you should be looking at is this Markdown slides package. If you look at that link that I put above, you'll see that it tells you how to install it. You can run this pip install with this link over here. And then you can generate the slides with that package using this command with empty slides and then the slides file. You can optionally specify the output directory, which by default, I think it's also this name. So in this case, it's not necessary. But then the more interesting stuff happens in the next couple steps, and we'll give you another minute to look into that. Okay, I guess it's all running low on time. I'm gonna keep going. So then the next step that I mentioned should use this actions upload pages artifact. And again, since this is just a GitHub repository, you can check out what the documentation says over there. And you'll see here that there's actually some sort of like template for how this should work. So it says that you can use it like this, specifying some path like this, and then that you can in a separate job, or if you prefer a separate just step, uh, you can have this actions deploy pages action, which it will do is that it will download the artifact that was created with this previous step. It will download it and then it will set up the rest of the pages that whatever needs to be set up. I'm not really sure what it's doing under the hood.
Yeah.
Yeah, but I guess since we're low on time, let me just cheat and I'll go here into.
Mind if I interrupt you quickly?
Oh yeah, go ahead.
Yeah, so before everyone leaves, I have a quick poll just to get some feedback on the talk. And Andres will finish up, but I wanted to launch the poll and not have people wonder what was going on. And we will make the recording and the slides available as well. And those you can find on the USRC webpage under the Education and Training Working Group section. Okay, go ahead.
Okay, so let me quickly. So what I did was I just looked at the commit history and I just looked at the workflow that was there before. So let me just create a new YAML file over here. Let me just paste this over here. You'll see that we have all the steps we discussed here. And then you like a bit more trickier parts are these new ones down here. So we upload the pages artifact where we're just uploading this slides directory that was created in the previous step. And then we have this other job where it's just using this actions deploy pages action. You'll see that we have to set up some extra permissions. Usually it's actually better to set them up like at the lowest level that you can. So like in this case, we're setting it up for the whole workflow, but I should probably only set them up for this particular job. Well, I'm just gonna keep them like this for now. And okay, so let me just show you. Oh yeah, and then in settings, you have to go over here to pages, then deploy from GitHub Actions. So let me just commit this. I'm gonna push. And Okay, I guess we're out of time. If you want to stick around to see what happens, you can. But yeah, that's basically it. So I hope that this was useful. With all these basic things, you can already set up like really good and powerful workflows. But there's lots more things to do and to learn, and it's actually pretty powerful. And yeah, so thank you for coming. I guess if you want to stick around to see how the deployment goes, you can. Let's check over here. Where did it go? Oh, yeah, this deployed. Oh, yeah, so at CI, you see succeeded. Let's look at here. It says that it was deployed here. And you'll see that those are just the slides that you were seeing from before. So this way you can deploy your own website if you want. Okay, so again, thanks for coming and hope it was useful.